Hello there. In this video, I'll be showing you how to make a more stable and better HUD in Game Builder Garage. So let's begin. So at this point, you're probably already familiar how to make your own HUD in Game Builder Garage, and most of it relies on this head Nodon. So if you're not too familiar, let me just give a short, brief explanation of the head Nodon. So the head Nodon is basically just a Nodon that you can connect stuff to. But the special part about it is it always follows the position of the camera. So for example, if I have this object and connect it in front, the Z position of the head nodon, the object will appear in front of the camera because the head nodon is where the camera is and it always follows where the camera is. So by connecting something to it, you can have something on the screen at all times. A few more information about the head nodon. If you look here into the Nodopedia, you'll see that it says here, connecting objects to it will attach to an invisible box object the position of the camera with the following dimensions: 0.5x, 0.4y, and 8z. And in addition, you can only directly connect one object to the head nodon, and there's a short list of objects that you can connect to it. So for example, you can't connect the free site connector objects to it and a few other different objects. But you can connect object nodons to it. So yeah. So just to help visualize things a bit, here I have this blue thing, which is actually the same dimensions as the head nodon and this sphere in the middle. So this will be our representation of the connections to the head nodon. So for example, if I connect this box to this object, so let me just make this solid first. So yeah, if I connect the head there, this is basically what it looks like when I connected that box to the head nodon, since this is the same dimensions as the head nodon. So since the head nodon is 8 meters long, if I connect a object in the Z face of the head nodon, that will mean that the object will now be connected 4 meters in front of the camera. So like this sphere is where the camera is, and if I put the camera where it is, yeah, we'll see the box exactly where we saw it earlier, 4 meters in front of the camera. So that's basically how the head nodon works and why connecting stuff in front of the head nodon works like that. So typically, if we're gonna make a HUD in Game Builder Garage, you'll just make use of this fact and connect a system of objects that will place your HUD objects in a specific position on your screen. So for example, here I have one set up already. And this setup, I connected this tall object in front of the head nodon, then this long object on top of that object, and then our HUD elements on the left and right. There's the camera, and if we connect this to the actual head nodon, you will see that when I connect this there, the HP and MP will show up on the corners where you might want your HUD elements to be. And for this additional objects, we can just make them invisible. And now you will have our HUD. So in most cases, for simpler games, this is already more than enough. Like you can move it around, and yeah, it works. But there's a few disadvantages with using this type of system. First off, you can see it already. If you have like a 2D game, for example, since these are actual objects in the world, they're just in front of the camera at all times, they will still cast shadows. So here, for some games, these shadows might be too distracting or might break the immersion of the HUD. So maybe you don't want that. Another thing is, since these objects are actual objects, like for example here we have boxes, if we have any touch sensors in the game, here I have a touch sensor connected to a texture that shows up when it detects a box. Well, since these are actually boxes, when we move our character close to that, or move the camera close to that, it will activate the touch sensor. So maybe in our game we want it to detect specific boxes, and since we have this HUD nodon which like is in the way, like when we move to a specific position, it might incorrectly detect a box there when it shouldn't. Another thing you might notice here is when we move around, that the HUD actually moves a little as well. And like if we connect a bunch of more objects, it will become more obvious. Like for example here, if you have a very complicated HUD, like here I just added a bunch of different objects. The more objects that you connect to it, the more obvious the instability of the whole system will look. And you can see here, whenever you move these other number of objects move very obviously. Yeah, so you can see here, since the HUD is in front of you, the camera. Well, depending on how you place the camera, some HUD objects might like go into the ground, or like when there's a wall here and move forward, oh, I can't see the HUD anymore because it's behind this wall. One more disadvantage with this type of setup is, well, what if you try to teleport somewhere very far away? You can see here when I try to teleport, it takes some time to catch up to you, and also you can see there like everything, all the slower parts of the HUD like take a while to catch up. So let me just show it again. Here it looks relatively stable, and when I come here, you can see like it bounces back, and you can see everything wiggle a little bit whenever it tries to stabilize. In the worst case, if if the connector objects that you use to connect all of your objects together here are relatively small. So for example here, I just like, this is an extreme example, but like for example here, well, it looks like your HUD looks perfectly normal, but when I try to teleport, you just heard something break there, and you see your flood basically like due to the force that's exerted on the HUD, and like trying to move it really quickly from that position all the way here. Some of the connections get broken, and your HUD just flies off into the sunset over there. So that's just a few of the problems that we have here. Oh yeah, and one last thing. Since everything here is connected to the head nodon, if you have a very, very complicated HUD, you might reach the object connection limit. So the object connection limit is actually a limitation in Game Builder Garage where, like, if you have a bunch of objects connected together, you can only have a maximum of 32. So once you go over 32, you won't be able to connect more to it anymore. So let me just try to reach that limit here. And that's still not enough. Let's add a few more. And here, yeah, you can see here, the number of objects when I try to connect this will exceed 32. So I can't connect it to it anymore. So like if you have like a bunch of different objects and you need to connect the HUD elements in like very specific positions, and you need to put a lot of these buffer objects to put them in the right place, this solution might not be enough, and you might hit the object connection limit. So let's try to solve all of those problems. First off, let's try to solve the jittery movement of the objects. So, why does the HUD jitter in the first place whenever we move? Well, here I have a setup that might explain that a little better. For example, there's our HUD, or there's our camera, and like we can move it around like that. So right now, it seems really stable. But the moment we connect a very heavy object at the end of it, for example, for here, you can imagine like you have a stick, a very light stick, and a heavy object at the end. When you try to swing it around and like try to stop the movement immediately, you might feel that the object will like still pull you forward because it's very heavy. And if you remember your physics, that's the first law of motion, the law of inertia, where if an object is already moving, it will keep trying to move. But here in this case, if we have a light stick and a very heavy object at the end, since the mass or inertia of the heavy object is much greater than the stick, like the total inertia of the system will be focused on the very heavy mass. So the mass or the heavy mass will win over the very light stick, and like wherever even if the stick tries to pulse back, the heavy mass will still win over it because it's much heavier than the stick. So like here, yeah, when if you try to move this around, the object will move first, but when we try to we try to stop it, when the stick tries to stop it, it will still keep moving forward because this thing is much heavier than the stick. There's two ways that we can solve this issue. Well, first, we can just make the object at the end much smaller. For example, here we have a sphere, and when we try to move it, it's much more stable. But there's still a little bit of jitter. You can see there at the like for one frame. But yeah, it's much more stable compared when we have this very vague object. Another thing we can do is, well, the object is very big and the stick is very light. Another thing we can do is just make the stick even heavier. So for example, if we make it 10 big, the stick is much bigger. When you try to move it, it no longer does that jittery thing because the masses or the inertia of the box becomes much closer to the stick. So like they're kind of balanced. They're more balanced and not one object wins over the other. So we can imagine that our HUD is kind of like this. If the weight at the end of the head nodon is way too heavy, this happens, like it becomes more jittery. And this problem becomes even worse whenever we connect more objects at the end of it. So like for example here, we just connect a few more objects at the end, and you can see at the very end it's even more unstable. So yeah, let's try to solve it then. So first, well, here in our original setup, moves a little bit. Well, we can use the first thing that we did earlier where, well, if the load is heavy, we can just make the stick heavier so that they're more balanced. So in this case, our stick is this first object we connected to the head. So if we just make this much bigger, you can see that the HUD moves much less than before. So that's one easy solution that we can do. You can just make it swizzle, and yeah, now we already have a better HUD. That's by figuring that mechanic out, or the weight, or need to balance the weight of the HUD compared to the thing that's carrying it. In this solution, we still have the same problem where we have a bunch of different objects that are connected to it, and yeah, it can't. Touch sensors can detect the stuff. So let's try to move towards a better solution. So what if instead of trying to offset our HUD to a specific position using a bunch of different objects, what if we just offset our HUD elements to that position immediately? How do we do that? Well, with a free side connector. So if you're not familiar with a free side connector, it just connects objects. It just offsets objects to another object based on the inputs you give to it. So for example, here I have a box. So let's say connect center to center. So normally, if I just connect a free sider there, the box is connected to the center of the blue object here. So nothing changed. But if we connect a 1 to the X input, the box will be offset by 1 meter to the right in the X direction. And yeah, doesn't even need to be connected. It's just offset based on that object. Like if you connect like Y, it will be offset by 1 in the Y direction. Connect the Z, so we offset 1 in the Z direction. So with the free side connector, we can just offset anything, whatever we want, without having these extra objects put next to each other to put them in the right position. So let's try to use that. So here I just have the same UI, which is the HP and the MP, and I just figured out the exact same offsets that we use to reach the same values here. So like, you can probably do some math to figure this out. And if we try to do this, well, first off, well, we're using free side connectors now. So first problem we reach is, well, We can connect objects to the head nodon, but we can't connect FreeSide connectors to the head nodon. So if we're gonna use any solution that requires FreeSide connectors, we need to connect a object first. So here we just connected center to center, and then we connect all of our FreeSiders to that one object connected to the head. So now we do that. We have the same setup using FreeSide connectors, but yeah, no more these extra stuff. And in this case, I just figured out the exact contents that I needed to offset these HUD elements in the right position. But now when we try to move, you might notice something. It goes haywire. So why does this happen? Well, now, if we go back to the stick metaphor, our stick is now this tiny box, and our load is these 4 boxes. So, like, these 4 boxes are much heavier than this one box. So, yeah, whenever you move, it becomes really unstable. So, easy fix for that is can make this much bigger. And now that our base is much bigger, when we try to move, now we have a much more stable setup. Let me just make the box invisible so that there's no shadow. And yeah, you have a better solution. Now we're able to do this HUD system without having a bunch of different connecting objects. And you might notice here, you might get worried that, well, this solution looks much more expensive. Like you're using these bunch of random constants to offset it instead of just using a few objects. But constants are one of the easiest nodons to shave because of location sensors. So if you're not familiar, location sensors, if you're not connected to anything, well, the location of the sensor will not move during the game. So these values will essentially be constant. So with a location sensor, you can actually save 3 different constants in just one nodon. So for example, here we have 3 different nodons to represent 3 different numbers. This location sensor I already put in like 1.85y and 4.4z, so I can just replace this 1.85 with this y input of the location sensor. And 4.4, I already have 4.4 in the z of the location sensor, so I can just connect this. Then for x, negative 2.8, I can just connect that and set the x of this to be negative 2.8. And now you have the same thing. So it's basically the same as normal constants, and like in some cases, by using this FreeSider connection setup, we might even save a few more nodons compared to this object offset setup. Okay. But now, well, we still have a few problems with the setup. Well, our setup is much simpler. We no longer have that bunch of boxes, but now we can, well, this can still detect the giant box that we have. And also it's still a little bit unstable. So like when we move around, it's much better than earlier, but it still can be improved a little bit. Let's try to figure that out. Okay, and also we still have these shadows, so we haven't fixed that yet. So the next thing we can do to make it more stable, like in our example earlier, well, we already made the stick bigger. What if we made the load smaller? So, well, we can try that. So if we try to make the load smaller, well now, well, maybe they're much more stable now, but you can see that they're very tiny and we can't see them anymore. But that's not a problem because we can just use perspective in our advantage here. So even if these are very small objects, if we put these objects closer to the camera, well, they would look bigger even if they're small. So we can just adjust our setup and find the exact coordinates that we need here such that these objects will be much closer to the camera and look the same size as we had earlier, but now they're smaller objects. So here I already figured out all of the constants here. And before we connect it to the head, let's connect it to the blue object first so that we can see how it looks like. So here This is the head Nodon, and this is the camera. And you see here, we have these tiny HUD objects. But now, like since they're tiny, I put them much closer to the camera. So you can imagine when you connect it to the head Nodon, even though these objects are very small, they will look very big relative to the camera. So let's connect it now. And you will see here, there, it looks exactly the same as before, but now they're actually really tiny. And since they're really close to the camera, well, they're really tiny and really close to the camera, we can't see the shadows anymore. So for 2D games, this kind of setup is perfect. You'll no longer see any shadows. And well, of course, depending on the sun direction, like if you look from above, you can still see them. There's still tiny shadows that you can see, but yeah, this is still much better than what we had earlier. And here I made a small change where instead of using this giant box object, I use a fancy object. Like in this example, just use a crate. It can be any object you want. It can be a cylinder, it can be a sphere, it can be a fancy object. I just use a crate because, yeah, like you can choose a specific fancy object that you never use in your game. And now, since now we have this crate fancy object and the objects are tiny now, with this old touch sensor, it no longer detects the HUD whenever we go close to it. So now we've solved the shadows part and the touch sensor detection part. Now, one thing you might be wondering about is, well, I get how this works, but how did you find these numbers? And to be honest, the answer there is just simple trial and error. So for example, here, when I started with no inputs, everything will just be at the same position as the camera, so the camera won't see it. So the first number that you should probably look for is the Z input, so that you can see where the number or where the objects are in the first place. For example, here, put 1Z, there, I get to see where the number is. So if it's not the size that I want it to be in the HUD, I just make it smaller and smaller until I reach the perfect size. And that's a little too big, so yeah, make it a little farther, and now it's about the size that I want. The next I just look for the other dimensions. So like for example, if I try to send 0.55 here, oh, find out that that's way too big, so let's try a smaller number like 0.2. And 0.2, that's almost close to what I want, so let's increase 0.2 a little bit more. 0.25, it's a bit too much. 0.23 maybe, and oh, that's perfect. Then lastly, I just look for the X input. So here, well, I want it moved to the left, so I need to send a negative value to it. So I send, say, negative 0.3. 0.3, it's almost there. Let's try other values, like maybe negative 3.5. And there we go. That looks about perfect, and I just do the same for all of my other stuff. Now, let's say you don't like the trial and error method and you want something more controlled, something more specific. Well, we can do something like this. So here we can just use a number object for our HUD. And then what we want to do is to display the current offset that we're sending to the freeslider to the object in our HUD. So like, let me just add a button here. Actually, it's better if you use a stick. Stick here, and then let's just divide the stick output by, let's say, 100, so that it moves much slower. So if we increase, so if I hold the left stick, it will increase the offset to the object, as well as show the offset I'm currently using to the object, and just move it until I reach the specific point. So like for example here, let's say to here, oh, I think to myself, oh, this looks perfect. Then I can just look at this number and see, oh, it's 0.55, 0.56. So yeah, I just figured out that the correct offset that I should put there is 0.55. And there we go. And just do the same thing for all of the other inputs. Like for example, the Y, I want to can just connect the counter to this again. Like slowly adjust it until I reach the correct value that I want. And if I find the value that I like, I just copy that number and send it to the freesider with a constant. But one more, or you can see here, there's still a little bit of a problem. Well, here on our HP, you can see that it's very stable, much more stable than earlier, but our MP here is still a little bit unstable. So why is that? Well, this is because we still have, or these objects are connected to each other. And when you get to like very tiny objects, the more objects that you have connect consecutively, the more unstable it will be. So like, let me showcase it here. So if I try to connect even more objects here to this HP HUD, when I move around, you'll see it will be very, very unstable. That's because the objects are much smaller now. So like, for example, here in this case, for this object, the stick for this object is now this object, and the stick for this object is this object, and so on. So like the more objects you have in consecutive connections, the more unstable it will be. So if we want our HUD to be perfectly stable, we need to make sure that all of our objects are not connected consecutively. So we want, instead of having this text object connected here and number object connected here, we just want everything to be connected directly to the stable giant object we have at the center of the head. So in this example, I already did it here. So now I have this giant fancy object, and all of our HUD elements are just connected directly to the fancy object through freeside connectors. And now if I try to connect this to the head nodon, now everything is perfectly stable and much more stable than before. In addition to this, now since our HUD objects are very small, when I get closer to objects, well, it no longer gets obstructed by other objects since it's really close to the camera. And the moment it gets obstructed, it's basically, that just means there's something right in front of your camera, so you're not going to see anything in the first place. Also, when I try to teleport to a far off place, well, it still takes some time for the HUD to get back here, but now how it looks like when it comes back is less obtrusive or less chaotic than before. Let me show that again. So it disappears and you only see it for a brief moment there before it goes back to a very stable position. So yeah, that's basically it for making a stable HUD. Just to give a few examples of that HUD in action, here's a few of my games where I use it. So for example, in Breed, this entire thing here uses that same principle. So in this case, like it looks relatively, or the shadow looks relatively large compared to the entire game because the whole game is shrunk down to a very small scale. When you look at the code, yeah, here's the head. Here's head nodon. Here's the stabilizer. So in this case, I use a cylinder because I think I had some box touch sensor somewhere in the level, and I didn't want this to like confuse any of those touch sensors. So that's why I use a cylinder. And yeah, I could have used a fancy object or whatever, but yeah, I just chose cylinder for no reason in particular. And yeah, here's our HUD elements. So here I didn't use the extreme setup where I had a freesider for every single object. So here I just had one freesider to connect the entire rewind clock system here. So like for example, here's a clock, and here's the background for the bar, and like here's just the extending object that I use for the rewind bar, and here's the hinge and the rotating hand for the clock, as you can see here. I guess, yeah. And you can see, yeah, the HUD is relatively stable. And then another example I have is here in Super Garage Odyssey. So I have a similar here, something similar here where, yeah, I just have this HUD where I have this sphere and the count of number of moons you've collected and also the controls menu. And when you look at the code, yeah, here's the head nodon, here's the stabilizing giant box. Then I just connected the cylinder right up to the box. So here I wanted to save a few nodon by just connecting nodons straight to the giant box. So that's fair as well. You don't need to always use a freeside connector if you can do something like this. And that's where I connected the clear the texture that shows up when you finish the game, as well as the texture for all the controls that you can toggle. And also here I have the freeside connector that's connected to the giant box, and yeah, that's connected to the sphere, and the numbers connected directly to the sphere. So in most cases, you probably don't want to do the multiple freeside setups if you don't need to. Like, you don't actually, like, the cases where you need it to be extremely stable is very small, and like just having one or two objects connected is pretty stable enough, and like I don't think anyone will notice it. So yeah, there's just a few examples of me using it in my games. So yeah, that's it for this video, and see you in the next one.